Okay, so we just got done with section 5.1, which was really solving with square roots and solving with C's in some sense. Um, the higher you get in mathematics, the more strategies you learn to solve problems. And it could be the case that one single problem might have 4 or 5 different ways that it can be solved. Part of the art of being a mathematician is knowing a variety of techniques and knowing when to use one technique as opposed to another, because sometimes one technique is infinitely harder than another. So what I was going to do is solve this problem using kind of the chapter 1 strategy, solving by factoring, the section 5.1 strategy, solving with C's, and then introduce what's new in section 5.2, which is a third way to solve the same problem. They all give me the same answers. So I'm going to try to do these in columns. So I'm going to solve the problem by factoring, and then by completing the square, which I would call the C method. And that's what we did in section 5.1, the bottom problems. And then something that's new to this section that's nice, probably most students eventually like this third way the best. So if this problem was in section 1.5, which you may or may not have done, you would, when you have a problem that has a square that's set equal to 0, if it's factorable, factoring is a quick and easy way to get to an answer. So this problem, it's easy even to factor it. So solving it by factoring would probably be the way I would choose if I wasn't told to use a specific method. So x squared plus 6x minus 7, I know that I don't need bottoms up because there's not a number in front of the x squared. I know that my signs have to be plus and minus. My lasts have to multiply to 7, subtract to positive 6. So going to be a positive 7 and a minus 1. If you FOILed that back out, you'd get exactly the line above it. If you're solving by factoring, once you get the problem both set equal to 0 and factored, then you split the factors up and set each one separately equal to 0. The x plus 7 factor, I'd minus 7 from both sides and get a solution of negative 7. The x minus 1 factor, I add 1 to both sides and get a solution of 1. So I'd say the answer to this is x equals negative 7 and 1. And I can check, and I always should check. Anytime I solve a problem with an equal sign, I should check. I'm going to check the negative 7 first. I'm going to go to the problem before I factor, just in case I messed up factoring, and go negative 7 squared plus 6 times negative 7 minus 7, and see if that equals to 0. Do that on my calculator because it's way quicker on my calculator. So negative 7 squared plus 6 times negative 7 minus 7. Hopefully it says 0. Because it says 0, I know that negative 7 is a solution. And now I'm going to check the positive 1 to make sure it works as well. So I'm going to go 1 squared plus 6 times 1 minus 7 and make sure that equals 0. So 1 squared plus 6 times 1 minus 7, and I get 0 equal to 0. So I know both of the answers are correct, and that is the only answer to this problem. When I solve it using the method from the last section and the method from this section, I'm going to get the same answer every single time. The factoring method is kind of my preferred method, solving problems that have an exponent of an x squared, but not every problem factors. Any problem in the last section that had an I for an answer or a square root for an answer, if you try to solve it by factoring, what you'd be trying to factor would be something that's prime. So factoring doesn't always work. So, but the C method, it could be nasty, but it's going to help you solve any problem that has an x squared and an equal sign. And it could get really nasty, but it doesn't matter if the problem factors or not. So in the last section, we learned how to solve problems that had an x squared by adding a c to both sides and making the letters on one side and the numbers on the other. So this is kind of a review of the last section. In the last section, I would have written this problem x squared plus 6x plus c equals 7 plus c. And then I would have figured out a number for c. I would have went c equals half of 6 squared. Half of 6 is 3. That 3 is going to come up in the factoring, and 3 squared is 9. So I'm going to rewrite the problem as x squared plus 6x plus 9 equals 7 plus 9. I'm going to factor the left side. Always when I use the C method, if I have the right C, it factors into two identical parentheses, and the number that goes in the parentheses is, you know, the thing before you square. So it's the half the middle number. So this left side is going to factor into x plus 3 times x plus 3. The right side is going to be 7 plus 9, which is 16. I'm going to rewrite this as x plus 3 quantity squared equals 16. And then I'm going to solve it by square rooting and plus or minus square rooting. On the left side, square rooting cancels out a square, makes it so I don't need the parentheses. I just need an x plus 3. On the right side, I have the plus or minus symbol. The 16 turns into a 4 when I square root it. I'm going to minus 3 from both sides and get x equals minus 3 plus or minus 4. Now I'm going to make the problems that are implied by the plus or minus. That would be x equals negative 3 plus 4 and x equals negative 3 minus 4. I could do those quickly in my head, but I'll do them on my calculator. The negative 3 plus 4 gives me x equal to 1. And the negative 3 minus 4 gives me the negative 7. So exactly the same answer, and that's shouldn't be surprising, because no matter what strategy I use to solve an equation, it only has certain answers, and the method shouldn't produce different answers. So this is kind of chapter 1. This is section 5.1. Quite honestly, this method of completing the square, I almost never, ever, ever use unless somebody forces me to use it. The only reason I teach it is because in Math 151, some teachers make a big deal out of this. But generally, it can be bypassed. Completing the square, it tells you something about the graph of that equation that you couldn't get by factoring or using this method that's going to be new to this section. But nevertheless, you might need to see it again. You might see it again in a higher class, but it's the method that I would never gravitate to this method if somebody let me have freedom on how to solve the problem. So the new method is this thing called the quadratic formula, and it's really a nice thing, or a nice formula. A lot of you have probably seen it before. More often than not, when I ask students to spit out the quadratic formula, they kind of mangle it a little bit. They remember it, and once they get used to it again, they like it, but they don't usually remember the formula perfectly. So the quadratic formula is this: negative b plus or minus the square root of b squared minus 4ac over 2a. Something you're eventually probably going to memorize. The quadratic formula can only be used to solve problems that the highest exponent is 2 that are set equal to 0. So to use the quadratic formula, the problem has to be set equal to 0, and the highest exponent can only be a 2. And in fact, it needs an x squared. The quadratic formula won't work if you had like an x cubed or an x to the 4th or an x to the 5th. In the last section, in section 5.5, we do some problems with x to the 4th, and a lot of students will try to do those with the quadratic formula, but the quadratic formula is specifically reserved for problems that are both set equal to 0, that the highest exponent is x squared. You'll notice that the formula has letters that I don't see in this problem. the letters for the formula are the numbers in front of the x terms and the constant itself. So the a in the quadratic formula is the number in front of the x squared. There's no number written there. It's assumed to be a 1, so the a is going to be a 1. The b in the formula is a number in front of the x term without the x, just the number. And the c is the number that doesn't have the letter. So the problem with set equal to 0, its highest exponent was 2. I can find values for a, b, and c and plug them into this formula. So I'm going to go x equals, because I'm solving for x, I'm going to create a fraction. I'm going to put a negative sign, because the formula has a negative sign. And then for the letter b, I'm going to put the number 6, because b is equal to 6. Then I'm going to put the plus or minus symbol that we got used to in the last section. And then under the square root, I get a b squared. I don't have a lot of room, and the b only needs to be in a parentheses if it's negative. So I'm just going to write 6 squared, and I don't really need a parentheses. And then a minus sign, and then the number 4, and then something to represent times. I'm going to put a times sign as opposed to a parentheses because I don't have a lot of room, but usually I'd use a parentheses. So 4 times a, which is I'll replace with a number 1, and then times c I'll replace with a number -7. And in the denominator, I'm going to get 2 times 1. I'm going to show you how to reduce this by hand, and then how to reduce it by your calculator. So if I'm working this by hand, which you'll probably not do except for this problem, I'm going to get the square root handled first. And under the square root, the first thing I see is 6 squared. 6 squared is 36. Another thing I see is -4 times 1 times -7. And if I do that, I'm going to get a positive 28. If I did that, -4 times 1 times -7, I'll get a positive 28. So under my square root, the b squared is 6 squared, which is 36. The -4 times 1 times -7 comes out to positive 28. And it's not that hard for me to do 2 times 1 in the denominator, so I'm going to change that to 2. Now the 36 plus 28, I'm going to simplify, and 36 plus 28 apparently is 64. So now I can write x equals -6 plus or minus the square root of 64, because 36 plus 28 is 64, over 2. I'm going to find the square root of 64 so I can get rid of the square root symbol. So I'm going to go square root of 64, which is 8. This is going to give me x equals -6 plus or minus 8 over 2. I'm going to reduce. If the denominator goes into both halves of the numerator, you're allowed to reduce the denominator into the numerator. If the denominator only goes into half of the numerator, you can't reduce it. But everything I circled is divisible by 2. When I divide the 2 by 2, I'll get a 1. The -6 by 2, I'll get a -3. The plus or minus 8 will turn into a plus or minus 4. So now I'm left with something that doesn't need to be a fraction anymore, because it just has a 1 in the denominator. So I'm going to get x equals -3 plus or minus 4. And magically, if you look at this right here, I lined them up perfectly. The completing the square, my second to last step, and my quadratic formula, the second to last step, they're exactly the same. So they're going to give me the same solutions. Then I'd go x equals -3 plus 4, and x equals -3 minus 4, and get the same answers of x equals 1 and x equal -7. So same problem solved 3 ways, only one set of solutions. Let me do the quadratic formula on my calculator. And unfortunately on my calculator it doesn't have a plus or minus symbol, so I'm going to run through it once with a plus and then a second time with a minus. So I'm going to have to do this twice to use my calculator to get the answer. So to get the 1 and -7, this is what I would do if I didn't want to do all this work by hand. I'd go fraction and then -6, and I'll do the plus first. There's no plus or minus key, so I'm going to do one time with the plus, one time with the minus, under the square root. If the b was negative, it absolutely have to be in a parentheses. Because it's positive, it doesn't matter if I don't put the 6 in a parentheses, but there's 6 squared, and then minus 4 times 1 times negative 7. So there's the entire numerator. And then in the denominator, 2 times 1. So this is only going to give me one of the two answers. And when I hit enter, it gave me the answer of 1. So I'm halfway done. I could probably this, and that step I could skip if I want to resort to my calculator. Calculator isn't good enough to be able to give me the answer for both. I think if I hit shift and equals, will it bring? Yeah, it brings the line back, which is really a nice thing. So I hit shift and equal, and what it allowed me to do is it allowed me to go back into the work I was doing. I might have been able to just arrow up there anyways. I'm going to play around as I go through the section because I'm not exactly sure what you can and can't do. But watch what I can do. I got back into the problem. I'm going to get right to the right of the plus key. Now I'm going to hit my delete key, and now I'm going to type the minus key. So rather than having to type that entire mess again, I just got up into the equation, and I got right to the right of the plus key. I hit the delete key, then I typed the minus key, and then when I hit equals, I got the second answer of negative 7. So I was able to be pretty efficient with my calculators. I didn't have to type this horrible thing in twice, but I can't do the plus or minus on my calculator. So I have to do the plus separately from the minus. Okay, so like I said, not all problems can be solved by factoring, and that's the case with problem 4. Problem 4, it's prime. You can't solve by factoring, but both the method of completing the square, the C method, and the quadratic formula can be used to solve problems that the highest exponents are 2, whether they factor or not. So I'm going to do the same problem two ways. So the first way is the way that's not really desirable, but the way I'm going to do the C method. The C method requires the numbers and the letters to be on the opposite sides. So if I'm using the C method, I'm going to add 3 to both sides and get b squared plus 6b equals 3. And then I'll save a line here because I'm going to run out of room. I'll go plus C, and C is going to equal half of positive 6 squared. Half of positive 6 is 3 squared, which is 9. So I'm going to rewrite this as b squared plus 6b plus 9 equals to 3 plus 9. I'm going to factor the left side. The left side factors into b plus 3 times b plus 3. The right side I get 12. I'm going to rewrite this as b plus 3 squared equals to 12. And now I'm going to solve. I'm going to go square root plus or minus square root. Left side is easy for me. Square rooting cancels out a square if the entire side is squared. Leaves me the b plus 3. On the right side, the plus or minus symbol doesn't go away, but the square root's reducible. The square root of 12 reduces to 2 times the square root of 3. So I'm going to write this as plus or minus 2 square root of 3. I'm going to minus 3 from both sides and get b equals to minus 3 plus or minus 2 square root of 3. If I tried to make the separate problems up, if I tried to go b equal negative 3 plus 2 square root of 3 and b equal minus negative 3 minus 2 square root of 3, neither one of those are simplifiable. They don't reduce. Like if I try to do negative 3 plus 2 square root of 3, my calculator's smart enough to know that doesn't reduce. You can't get a negative 1. You can't add something without a square root to something with a square root. Similarly, the second one, negative 3 minus 2 square root of 3, I'd get, again, something that doesn't reduce. Because neither one of these, if you make them with just the plus or just the minus reduce, you shouldn't make a separate problem. You shouldn't make a separate problem with the plus or the minus. And I'm going to make this the answer. I'd like to check it, but another way of checking is solving the problem using another method. If I get the same solution using both methods, I feel good about my answer. So instead of checking it the real correct way, I'm going to check it by solving the problem using the quadratic formula. If I get exactly the same answer, then the chances of me making mistakes in both methods and getting the same answer is so slim that I'm going to believe my answer is correct. So it's kind of unfortunate that I have the letter B in this problem, but I can deal with it. So the quadratic formula needs the problem to be set equal to 0. It needs to have a squared for the highest exponent. Once you have the problem set up like that, the a is the number in front of the squared term, the b is the number in front of the first power term, and the c is the number without the letter. So the quadratic formula absolutely needs the problem to be set equal to 0, and it doesn't work for fourth powers, third powers. It only works if the highest exponent is 2. I'm going to plug the numbers into the formula. I'm going to write b equals, because the letter in the problem is b, and I'm going to do a negative sign from the formula, and then a 6 for the b, and then a plus or minus from the formula, a square root symbol from the formula, and then if the b is negative, it has to be in a parentheses. If the b is positive, it doesn't really have to be in a parentheses. So I'm going to go 6 squared minus 4 times 1 times negative 3 for the 4 times 1 for A, negative 3 for C, over 2 times 1, which is 2 times A. I'm going to do it by hand, and I'm going to do it on my calculator. So by hand, under the square root, I'm going to work first. I'm going to go negative 6 plus or minus, and then the 6 squared is going to be 36. So the 6 squared part of this is going to be 36. And then the minus 4 times 1 times minus 3, two negatives turn into a plus. I get a plus 12 over 2. The 36 plus 12 is going to give me a 48. So I'm going to get b equals negative 6 plus or minus the square root of 48 over 2. Let me reduce the square root of 48. So I'm going to go square root of 48 equals to 4 square root of 3. So now I'm going to go b equals negative 6 plus or minus 4 square root of 3 over 2. And just like the last problem, the denominator went into both halves of the numerator outside the square root. So all three of those things I'm going to reduce by 2. Negative 6 divided by 2 is going to be negative 3. 4 divided by 2 is going to be 2. 2 divided by 2 is going to be 1. So I don't need to write a fraction for this answer because there's only going to be a 1 in the denominator. What's left is a b equals, the first thing in the numerator is going to be a negative 3. I still have a plus or minus sign. Then the 4 turned into a 2, and the square root of 3 after that square root didn't go away. If you look at this and you look at that, those match perfectly, so I feel good about my answer. Let me do this by my calculator and see if I can figure out quick ways to do the plus or minus. So on my calculator, I'd go fraction negative 6. I'll do the plus first. Plus square root 6 squared minus 4 times 1 times negative 3 over 2 times 1. And this is going to give me the plus part of this. So the first thing I got was this, negative 3 plus 2 square root of 3. I'm going to see if I can just use my arrow. No, I can't. Oh, I used my left arrow. So I just hit my left arrow, and hitting my left arrow got me into this problem that I just did. And now I'm going to change the plus to minus. So I used my left arrow, I got into this thing that I just typed in. I'm going to hit the delete button once my cursor is flashing right to the right of the plus sign. I'm going to change it to minus and hit equals. And that tells me that I get negative 3 minus 2 square root of 3. So these are the two solutions that come up. And since it's more efficient to write a plus or minus symbol because I can see those two individual solutions from writing the solution once with a plus or minus symbol, then that's the way I'm going to write it. Okay, the rest of the section is just doing quadratic formula over after quadratic formula after quadratic formula. It's good to kind of beat it to death. And I'm going to rely on my calculator probably more than I should, but I don't mind using my calculator. So 6 is set up perfectly for the quadratic formula. The a is the number in front of the term with the exponent of 2, which is 1. The b is the number in front of the first power term, which is 10. The c is going to be -9. Again, I need negative b plus or minus the square root of b squared minus 4ac over 2a. This can be solved by factoring. No, it couldn't just be solved by factoring. It's actually prime. So I'm going to go z equals, and then negative b is going to be -10. And then the plus or minus symbol. If the b was negative, it'd have to be in a parentheses. It's not negative. It doesn't have to be in a parentheses. So 10 squared minus 4 times 1 times -9 over 2 times 1. And I'll do it by hand the best I can. Z equals -10 plus or minus 10 squared is going to be 100. -4 times 1 times 9 is positive 36. And then over 2. So I get z equals -10 plus or minus the square root of 136 over 2. It's illegal to reduce these two. If I did this on my calculator, I wouldn't be tempted to reduce this. Let me reduce the square root of 136 real quickly, which is 2 square root of 34. So I'm going to get z equals -10 plus or minus 2 square root of 34 over 2. Because the denominator goes into something outside the radical on both sides of the plus or minus sign, it's legal and I should reduce. The 2 is going to go to a 1. The -10 is going to reduce to a -5. The positive 2 is going to reduce to a 1. I think my answer is going to be z equals -5 plus or minus the square root of 34. When there's a square root after the plus or minus sign, I never take the time to make a separate problem, one with a plus, one with a minus, because you can't add or subtract a number without a square root to a number with a square root. I'm going to do the same thing on my calculator. If I get the same answer doing this on my calculator, I'll feel really good, but I'll still check it, and I'll show you how to check it by hand. So this on my calculator, fraction -10, then I do the plus square root of 10 squared minus 4 times 1 times -9 over 2 times 1. And I get -5 plus the square root of 34. I'm going to use my left arrow. I'm into the equation I've just been working. And I keep left arrowing. I get my cursor to the right of that plus sign. I hit the delete button. Then I type the minus key. And then hit equals. And I get -5 minus the square root of 34. So I could see the two answers that I just came up with are the answer that I came up with of -5 plus or minus the square root of 34. Let me check it. I usually get lazy and don't check with the quadratic formula because I don't make that many mistakes when I use my calculator. But the original problem, 10z squared plus 10z minus 9 equal to 0. If I wanted to check z equal -5 plus the square root of 34, this is going to be tight. I'm going to go -5 plus the square root of 34 squared plus 10 times -5 plus the square root of 34 minus 9, and that must equal to 0. So I'm going to enter this mess. So I'm going to go parentheses -5 plus square root of 34 squared plus 10 times -5 plus the square root of 34 minus 9. when I hit enter, if I get 0, I did perfect. So this gives me 0 equal to 0. And now I'm just going to go back and change that plus to a minus, that plus to a minus, using my left arrow key, getting back to the line that I just worked with. First plus I'm going to change to a minus, and then, or second plus I change to a minus, first plus I'm going to change to a minus. So without having to enter this horrible thing again on my calculator, I went and changed each of these pluses to minuses to give me the second solution. And when I hit enter, I also get 0 equal to 0. So both solutions I've checked. Sneaky ways, I guess. So I've checked them both, so I know they're both right. 8 is still a friendly-ish problem. The a is the number in front of the square term. Since I don't see a number, it's assumed to be 1. The b is the number in front of the first power term. The c is the number without the letter. Again, the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go d equals fraction negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 1 all over 2 times 1. This is kind of a special problem. It's one of the rare problems where you only get one solution. So let me work on this by hand, then I'll do it on my calculator. I'm going to get d equals negative 2 plus or minus, and then under the square root, 2 squared is 2 times 2, which is 4. 4 times 1 times 1, or negative 4 times 1 times 1 is negative 4 all over 2. So under the radical, I'm going to get a 0. I'm going to get negative 2 plus or minus the square root of 0 over 2. And 0 is one of the two numbers that is its own square root. The square root of 0 is 0. So this is d equals negative 2 plus or minus 0 over 2. So I'm going to get d equal negative 2 plus 0 over 2, and d equal negative 2 minus 0 over 2. This one, first one comes out to negative 2 over 2. The second one also comes out to negative 2 over 2. So there's only one answer. This is a very unique problem. The only answer to this is d equal to negative 1. Let me do all this up here by my calculator, and then I'll check it. So calculator work, so fraction negative 2 plus square root 2 squared minus 4 times 1 times 1 over 2 times 1. Hopefully I see negative 1 when I hit enter. I do. Now I'm going to left arrow and do my best to get to that plus sign in the numerator of that quadratic formula. I'm going to hit the delete key, change the plus to minus. This is going to give me the second solution. Hopefully it also says negative 1. And it does. So there's only one answer. When we get the same answer for the plus and the minus, we say that that answer has multiplicity 2, means it comes up twice. That's a deal in college algebra, but not now. So let me check. I only have one number to check. So I want to check to see if d equal negative 1 works. I'm going to go, does negative 1 squared plus 2 times negative 1 plus 1, does that equal to 0? Being lazy, it's not that hard to do that by hand. It's probably insulting to use my calculator to do something so trivial. So I just entered the left side, and the left side simplifies to 0. The right side's already 0, so I know my work is correct. So a series of really nice problems. It's nice when the a is 1. It just makes it easier for me. So in this problem, again, I'll keep writing this down, but hopefully eventually you get it memorized. So I'm going to go a is 1, b is negative 3, c is 5. I'm going to go x equals, first time the b is negative, I need a parenthesis here, so I'm going to go fraction negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 5 all over 2 times 1. This double negative is going to go to a positive 3. Usually I won't even enter a double negative. I'll just I'll write it as a positive initially. Under the radical, negative 3 squared is a positive 9. So negative 3 squared is 9. 4 times 1, negative 4 times 1 times 5 is minus 20. And 2 times 1 is 2. This gives me x equals 3 plus or minus the square root of negative 11 over 2. I'll never leave a negative under a square root. I'll always produce an I. I don't think this can be reduced. The square root of 11, 11's a prime number, it doesn't reduce. It wouldn't make sense to make a separate problem, one with the plus, one with the minus, other than for checking purposes. Because if I did, if I tried to simplify fraction 3 plus square root of 11I over 2, my calculator is just going to tell me this can't be reduced. Well, it made it into 2 fractions, which is almost less desirable. When we did the section 410, I often write my answers like this, and my calculator doesn't like it, but these are equal to each other. It's written differently, but it's not reduced. Let me do this on my calculator. On my calculator, if I wanted to do the double negative, I'd go negative and then parentheses negative 3 plus first square root parentheses negative 3 squared minus 4 times 1 times 5 all over 2 times 1. And I bet you it's going to give me this. It's probably going to give me that 3 over 2 plus the square root of 11 over 2I. So you can see the pieces a little bit, but it's going to be a little different than what I got by hand. And see, it likes to do that. It doesn't like to have a numerator with an I in it. It breaks it into 2 pieces. That's the way it's programmed. Let me go back and change the plus to a minus, and the best I can, I'll show you that my answer is just fine. So when I do this, it's going to give me this answer, but with the minus. And there you can see it. So this is generally how I'd write my answer. My calculator likes this version better. They're equal to each other. So I'm going to say this is my answer. You can definitely say this is your answer. I really don't want to check this, but I will. I'm going to check this version. So I'm going to go for my checking. Try to squeeze it in here. It's hard to squeeze it. I'm going to go I'm going to go 3 plus the square root of 11 times I over 2 squared minus 3 times 3 plus the square root of 11 times I over 2 plus 5. That best equal to 0. That's a heck of a lot harder to enter than anything that I've done so far, I think. So, parentheses, fraction, 3 plus the square root of 11, get out of the square root, type your I, which is the ENG key, over 2, get out of the denominator, parentheses squared, so that's the beginning part, and then minus 3 parentheses fraction 3 plus the square root of 11 I over 2 parentheses plus 5. When I hit equals, it gives me 0. So good. So that answer is right. Now I'm going to back arrow, start changing pluses to minuses. So the plus right between the 3 and the square root, I'm going to change to minus in both parentheses. And that's checking the minus part. So I double changed each of the pluses to minuses, and I got a 0 equals 0 again. So I know both answers are right. So I've checked. And again, I often don't check on quadratic formulas. Just I get lazy because that's a pain to check. 12 is going to have a nice answer, but it has issues going on. The A isn't 1 and the B is negative. That's kind of the worst case scenario. So I'm going to use negative B plus or minus the square root of B squared minus 4AC all over 2A. I'm going to write T equals fraction negative 7 plus or minus the square root of negative 7 squared minus 4 times 3 times 4 over 2 times 3. I'm just going to be lazy and not even do it by hand, but I could do it by hand. It's not that hard to do with my calculator. So negative parentheses negative 7. I could have just entered a positive 7 plus square root negative 7 in parentheses squared minus 4 times 3 times 4 over 2 times 3. Wow, gives me t equals to 4/3. Nice answer, easy to check. I'm really good at check that. I'm going to go backwards now so I can get the minus answer. So I'm doing a bunch of backtracking. Got right by that plus that I need to change to minus. Delete it, change it to minus. It equals, and I get 1. Let me check both of these. These are friendly to check. So to check t equal to 4/3, I'm going to go 3 times 4/3 squared minus 7 times 4/3 plus 4, and hopefully that equals to 0. If it doesn't, I made a mistake somewhere. So 3 parentheses fraction 4/3 parentheses squared minus 7 parentheses fraction 4/3, close out my parentheses, plus 4. That better say 0, and it does. So I've checked the 4/3. Now I'm going to check the 1 and go 3 times 1 squared minus 7 times 1 plus 4. Make sure that equals 0. Again, I go back to my original problem. So 3 parentheses 1 squared minus 7 times 1 plus 4. And I get 0 equal to 0 again. So I feel good. I've checked the answers. I got lazy. I don't mind you being lazy on the test and doing this, because this is just arithmetic in some sense. So if you want to speed through down your calculator, you're welcome to do it. And I'm going to start just really relying heavily on my calculator. 14, it's going to be a equal to 2, b equal to negative 6, c equal to 5, and I'm not going to write the formula down. Hopefully you have it in your head or in front of you. So I'm going to go negative 6 plus or minus the square root of negative 6 squared minus 4 times 2 times 5 over 2 times 2 for the 2a. On my calculator, I could just as well enter that as a positive 6 rather than typing the double negative, because I could turn to positive 6. So I'm going to go positive 6 plus square root parentheses negative 6 squared minus 4 times 2 times 5 over 2 times 2. And I get, I'm going to write it like this. I'm going to write it 3 plus 1i over 2 as opposed to my calculator's answer. The calculator answer is fine. It's just not what I would normally get if I was doing it by hand. And I condense those two fractions into one, pop the I up in the numerator, backtrack to see what I'd get with the minus. So delete, minus, enter, and I get the same thing with a minus. So I think this is the answer, and I'm going to make my effort at checking. So for the first one, I'm going to go 2 times 3 plus I don't need the 1, over 2 squared minus 6 times 3 plus I over 2 plus 5, and see if that equals to 0. So 2 parentheses fraction 3 plus I over 2 parentheses squared minus 6 times parentheses fraction 3 plus I over 2, close my parentheses, plus 5. Hopefully that says 0. It does, so that works. Now I'm going to change the pluses to minus to make sure those work. So first plus, delete, make it a minus. Next plus, get over to it. Delete, make it a minus. If I get another 0, they both have checked, so I've checked them both quickly. Let me show you this by hand. Not that you really want to do it by hand, but if I was doing this by hand, I'd go t equals to positive 6 plus or minus. This is going to be positive 36 minus 40. So it's going to be negative 4 under the radical. The denominator is going to be 4. and then the negative 4 has a square root of 2i. So this is going to be t equals 6 plus or minus 2i over 4. And each of the things that I circle, I'm going to divide by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. 4 divided by 2 is 2. So this is going to give me 3 plus or minus 1i over 2. That was almost easier for me than doing it with my calculator. But for what it's worth, they're both okay. You don't need the 1 in front of the I, but it's definitely okay to have. I'm wearing out and not even to the last problems yet. So 16, a equals to 9, b equals to negative 12, c equals to 4, x equals negative 12 plus or minus the square root of negative 12 quantity squared minus 4 times a, which is 9, times c, which is 4, over 2 times a, which is 9. Calculator time. This double negative, I'm going to make a positive. So fraction positive 12 as opposed to double negative, plus square root parentheses negative 12 squared minus 4 times 9 times 4 over 2 times 9. Oh, 2/3. What a lovely answer. Backtrack. Get that plus change to a minus. Recalibrate. Oh, I can't get 2/3 again? Thought means that came out to be 0. 36 times. Oh, yeah. I'll be darned. If I was doing this by hand, this wouldn't have surprised me so much, because under the square root, negative 12 squared is 144. 4 times 9 times 4 is another 144. If I was doing this by hand, I'd get x equals to 12 plus or minus the square root of 0 over 18. When the square root comes out to be 0, you only get one answer, because this would be 12 plus or minus 0 over 18, which is 12 plus 0 over 18, and 12 minus 0 over 18. Each of these reduces to 12 over 18, which is 2/3. I'm going to check because I can. Easy to check this nice pleasant number. I'm going to go 9 times 2/3 squared minus 12 times 2/3 plus 4. Make sure that equals to 0. So 9 parentheses fraction 2 over 3 parentheses squared minus 12 parentheses fraction 2 over 3 plus 4, and I get 0 equal to 0, and that's exactly what I need it to be. So the first 16 problems, this middle group of problems were really, in some sense, nice. They were perfectly set up for the quadratic formula. The quadratic formula requires the problem to be set equal to 0, the highest exponent to be 2, and me to have 3 individual pieces on the left side. You'll see in the next group of problems, the problems aren't set up for the quadratic formula, and I'm going to get them set up for the quadratic formula. I always put a problem like 18 on the test, and students miss it all the time because this is not set up for the quadratic formula. The quadratic formula very specifically needs the problem to be set equal to 0. If the problem isn't set equal to 0, then you're going to pick off some signs that are going to be wrong. When I go to check, I'm going to check into the original problem. I don't want to check into something that I've changed because I could have made a mistake on the first step. So I needed to, in the instructions, it says rewrite it with it set equal to 0, and it's best to have the a positive. It's not a deal breaker. I could have moved everything to the right hand side and had a negative 1 for my a, but it's a lot nicer, especially when you're working by hand, to have the a positive. So if you didn't subtract 10 from both sides and made c equal to positive 10, the answer you got wouldn't check. So again, I'm going to use x equal to negative b, which is negative 9, plus or minus the square root of b squared. Since b isn't negative, it doesn't need to be in a parentheses, but it's okay to have it in one. minus 4 times a times c, which is 4 times 1 times negative 10, over 2a, which is 2 times 1. I'll do it by hand and then I'll use my calculator. 9 squared is 81. I have a double negative here, so I get a plus. 4 times 1 times 10 is 40. Under the radical, I'm going to get 121. So this is going to be x equals negative 9 plus or minus the square root of 121 over 2. Square root of 121 is 11, so I get x equals negative 9 plus or minus 11 over 2. Make my two problems. X equals negative 9 plus 11 over 2. X equals negative 9 minus 11 over 2. The negative 9 plus 11 is going to be negative 2 over 2, which is negative 1. This next one's going to be negative 20 over 2, which is negative 10. I think my answer is x equal negative 1 and negative 10. Most students won't ever want to do this. I don't care if you press some buttons. I'll do it. I'll show you on my calculator how to do it. So I'm going to go fraction negative 9 plus fraction square root 9 squared minus 4 times 1 times minus 10 over 2 times 1. Get the first solution of 1. Backtrack. Change that plus to a minus. Get the second solution of negative 10. Absolutely, if you had the c equal to positive 10, you wouldn't get those numbers. And they wouldn't check. So let me check first, negative 1. I'm going to go, does negative 1 squared plus 9 times negative 1 equal to 10? Really? Oh, this is a mistake right here. This is negative 9 plus 11. This should have been positive 2 over 2, which should have said positive 1. I bet you when I did it on my calculator said positive 1, and I just ignored it. Let me backtrack. Delete plus equals. It should have been positive 1. I had a math error here. Negative 9 plus 11 is positive 2. Positive 2 over 2 is positive 1. I should be checking positive 1. That's the danger of trying to do the math in your head. I think I could do the math in my head quicker than I can on my calculator, but I made a silly mistake, which I never would have made on my calculator. So checking the 1, I'm going 1 squared plus 9 times 1, that better equal to 10. And it does, so I'm good with that. So definitely positive 1 is the solution. Now let me check negative 10. I'll go negative 10 squared plus 9 times negative 10 and see if that equals to 10. So negative 10 quantity squared plus 9 times negative 10 equals, and I get 10 equal to 10. So I've checked both solutions, screwed up when I did it by hand. So my answer should be x equal to 1 and negative 10. Blew a sign there, which made the sign wrong on my by hand work. The reason I started to catch it because in my checking, I started doing the checking in my head and it wasn't working, and so I started searching for my error and I found it. I would have never made that error if I did it all by hand. 20 is similar to the last problem because it's not set equal to 0. If you don't take the time to set the problem equal to 0, the quadratic formula doesn't work. The quadratic formula has to have each 3 individual pieces, one with a squared term, one with the first power term, one with a term without a letter, equal to 0. If it's not equal to 0, if you have exponents like 3 and 4, it doesn't work. So this one's a is going to be 3, b is going to be negative 6, c is going to be 2. I'm going to go x equals negative b, which is negative 6, because the negative b comes from the formula, so I get double negative there because the b is already negative and there's a negative in the formula. And then plus or minus the square root of b squared minus 4 times a, which is 3. This time I use parentheses for my times. It doesn't matter if you use parentheses or if you use times. I'm not going to try this on my calculator. Apparently I'm by hand. Apparently I'm wearing out. So I'm going to go fraction. I'll make the double negative positive and go 6. And then plus square root parentheses negative 6 squared minus 4 times 3 times 2. I use times instead of parentheses. over 2 times 3, and I have 3 plus the square root of 3 over 3. I'm going to backtrack now, change that plus to a minus. Delete, plus goes to minus. I get 3 minus the square root of 3 over 3. So I think this is my answer with the plus or minus sign. And I'm going to check because it doesn't take that long to check. It's not that hard to check. So for the first one, I'm going to go to the original problem. The original problem before I did anything is 3x squared minus 6x equals negative 2. So I'm going to go 3 times 3 plus the square root of 3 over 3 squared minus 6 times 3 plus the square root of 3 over 3, and that better equal negative 2. Otherwise, my answer is not correct. So clear it. 3 parentheses fraction 3 plus square root of 3 over 3 parentheses squared minus 6 parentheses fraction 3 plus square root of 3 over 3, not 2. Close out my parentheses. Better say negative 2 when I do that. And it does. So I've checked the one with the plus. I'm going to back up and change my pluses to minus. So there's 1 plus, delete, change it to a minus. There's the other plus, delete, change it to a minus. That one also works. Usually if you have a plus or minus in your answer, if the plus works, then the minus is going to work as well. It's, I can't think of a case where that won't happen. So you can probably cheat a little on your checking. 22 is a little bit trickier. It's not set equal to 0. I need to set it equal to 0. So I'm going to add 5y and minus 4 from both sides. On the left side, when I add 5y and minus 4, it doesn't combine with the y squared, but I better write it in a nice order. So the quadratic formula needs the problem set equal to 0. It needs 3 individual pieces on one side, 0 on the other. And on the left side, I canceled out the 4's and the 5y. On the right side, multiplication or addition is commutative. I wrote the 5y first because that's before the 4, because that's the way it makes it easier to get the right A, B, and C. The number without the letter should be last. But if you wrote it backwards, you can still get it right if you get the right A, B, and C. In this problem, the A should be 1, the B should be 5, the C should be negative 4. I'm going to go negative b, which is, so y equals negative b, which is negative 5, plus or minus the square root of b squared, which is 5 squared, minus 4ac, which is 4 times 1 times negative 4, over 2 times 1. I'm definitely fatigued, which means you've got to be more fatigued than me because this is not that hard for me. It's not new. So fraction, I'm bailing and using my calculator probably more than I would generally. Messed up on the wrong negative sign. So there's the one with the plus. I get negative 5 plus the square root of 41 over 2. I'm going to gamble and think the other one has the minus, and I'm going to check them both. Checking them here, I need to check both sides. That's really unpleasant. So for the checking, I'm going to check negative 5 plus the square root of 41 over 2. Put it in the original problem was y squared equals 4 minus 5y. So I need to do negative 5 plus the square root of 41 over 2 squared and show that that equals 4 minus 5 times negative 5 plus the square root of 41 over 2. So I need to do 2 checks. I need to do the left side and the right side because the original problem there had y's on both sides. So left side comes out to be fraction negative 5 plus the square root of 41 over 2 quantity squared comes out to be 33 minus 5 square root of 41 over 2. I'm going to work on the other side. On the other side, I'm going to go 4 minus 5 parentheses fraction negative 5 plus the square root of 41 over 2. and I get, beautiful, 33 minus 5 square root of 41 over 2. I'm rolling the dice twice here. I've never come across a problem where checking a plus worked and checking the minus didn't, so I'm assuming the minus worked. And I didn't even do this minus on my calculator. Let me do that real quick just to make sure. I'll do this with the minus. Negative 5 minus square root 5 squared minus 4 times 1 times negative 4 over 2 times 1. And I get the exact same thing. Oh no, it factored out a minus on me. So it gave me this. Negative of 5 plus the square root of 41 over 2. This minus, it distributes through the parentheses, attaches to that plus, and changes that plus to minus. So my calculator, when this answer that should have been negative 5 minus the square root of 41 over 2, it factors out that negative, dumps it out in front of the parentheses, or front of the fraction, and writes it like that. I don't know why it does that, but when I do it by hand, it doesn't do that. So this is the best answer for this problem 22. If you wanted to, you could say negative 5 plus the square root of 41 over 2 and negative 5 plus, like that, with the negative written not in the numerator but to the left of the fraction. That means the negative applies to both. Kind of like my calculator did it better than I could do it, like that. But I wouldn't generally do that. Few more. I might end this without doing every single problem. I want this problem to be set equal to 0. It's really easier, especially by hand, if the a is positive. So I'm going to, for the first time, wind up with a 0 on the left-hand side. And it really doesn't matter which side the 0 is on. So on the left side, I add 5y and add 6y squared. That's going to zero out the left-hand side. The three things I have on the right-hand side can't be combined. I can write them in any order that I want, and probably the nicest order is 6y squared plus 5y plus 4 for the quadratic formula. If you would have subtracted the 4, not rewritten, and had a negative, you'd have all negatives, and that's a lot harder to work with than all positives. So for me, my a is going to be positive 6, my b is going to be positive 5, my c is going to be 4. I'm going to get y equals to negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 6, times c, which is 4, over 2a is 2 times 6. So again, thank gosh for this. Fraction, negative 5 plus square root 5 squared minus 4 times 6 times 4 over 2 times 6. And I get an I, and I'm going to jumble that back together. I'm going to write negative 5 plus the square root of 71 times I over 12. And my calculator, when I do the minus now, if I go back into that problem, change the plus to minus, delete, make the plus a minus, I get the same answer with a minus between, so the plus or minus symbol is appropriate. And let me check one of them. I don't want to check both of them, just wearing out. And if one works, the other is going to probably work. So the original problem was negative 5y minus 6y squared equals to 4. I'm going to check the one with the plus. I'm going to go negative 5 times parentheses, negative 5 plus the square root of 71i over 12 minus 6 times this horrible thing squared, negative 5 plus the square root of 71i over 12, and make sure that equals to 4. And again, my answer should be this. Y equals negative 5 plus or minus the square root of 71 times I over 12. Checking it best I can here. So clear, negative 5 parentheses fraction, negative 5 plus the square root of 71, get out of the square root, get my I over 12, close out the parentheses, and then minus 6 parentheses fraction, negative 5 plus the square root of 71 I over 12 this one's squared, so parentheses squared. And when I hit equals, it better be 4 because the right-hand side is 4. And it gave me 4. If I didn't have a calculator that would do this, I would not do this in a million years by hand. Let me change the pluses to minus to make sure the minus one works. So there's the first plus, change it to a minus, second plus, change it to a minus, and I get the same 4 equals to 4. So I've checked both solutions. I know that answer is perfect. Just a few more left, and the few more that are trickier. So 26, 28, 30. Oh, I don't know if I do them all or not, but I'll do a few of them. These parentheses are useless for the quadratic formula, so I need to clear the parentheses in the rest of the problems. To clear this parentheses, I have to FOIL firsts, outers, inners, and lasts. So quadratic formula requires the problem to be set equal to 0, and I need 3 distinct pieces, not a bunch of parentheses. So I FOILed out the parentheses. The outers and the inners have the same signs. I'm going to combine those to get a minus 7x. So I'm going to get x squared minus 7x plus 12 equals to 2. Need the problem to be set equal to 0, so I'm going to minus 2 from both sides. So 26 took a ton of preparation to get the problem ready for the quadratic formula, because to use the quadratic formula, I need an x squared. I can't have an x cubed or an x to the 4th or an x to the 5th. Need 3 individual pieces set equal to 0. Now that I have that, my a is going to be 1, my b is going to be negative 7, my c is going to be 10. I'm going to go x equals negative b, negative 7, plus or minus the square root of negative 7 squared minus 4 times a, which is 1, times c, which is 10, over 2a, which is 2 times 1. Double calculator here. This double negative I'm going to make positive. So I'm going to go, if you can see it there, I'm going to go fraction positive 7, and then plus square root negative 7 squared minus 4 times 1 times 10 over 2 times 1. And I get, well, lovely number 5. So one solution, I think, is x equals 5. Now I'm going to backtrack, change that plus to a minus, and I get 2. Which nice answers. Let me check these. So the original problem said x minus 3 times x minus 4 equal to 2. Let me check 5. I'm going to do, it does 5 minus 3 times 5 minus 4 equal to 2. This is so easy, I'm not even going to use my calculator, because this gives me 5 minus 3 is 2, 5 minus 4 is 1, and 2 times 1 equals to 2, so 5 checks. If I want to check the 2, it's a little bit harder. I go 2 times 3 times 2 minus 4 and see if that equals to 2, going back to the original problem and changing my numbers to the answer. So 2 minus 3 times 2 minus 4, beautiful, that gives me 2 equal to 2. So those answers both checked. Let me keep mushing along here. Let's see where I wind up. I have a same problem with 28 that I did with this last problem. It's not set equal to 0. I don't see 3 individual pieces. I'm going to clear the parentheses on the left side by going 3x times x and 3x times minus 1. 3x times x gives me a 3x squared on the left side. 3x times minus 1 gives me minus 3x on the left side. I see 3 individual pieces, but it's not set equal to 0, so I'm going to get it set equal to 0 and go 3x squared minus 3x minus 6 equal to 0. Now I have it set up so I can pick off my a for 3, my b for negative 3, my c for negative 6. X equals negative b, which is a negative 3, plus or minus the square root of negative 3 squared minus 4 times 3 times negative 6 over 2 times 3. Too tired to do it without my calculator, so calculator time. Fraction, positive 3, making that double negative a positive, and then plus square root, parentheses, negative 3 squared minus 4 times 3 times negative 6 over 2 times 3. What a lovely answer again. X equal to 2. Backtrack, change that plus to a minus. Second answer, negative 1. Really nice answers, thank gosh. So I'm going to check each of these. First one, the original problem is 3x times x minus 1 equals 6. That's better where I check. If I don't check there, I may have made a mistake on the first step that I don't see. So I'm going to try the 2. I'm going to go 3 times 2 times 2 minus 1, see if that equals to 6. Do this parentheses. That parentheses comes out to 1. I get 3 times 2 times 1 equal to 6. That one I didn't really need my calculator for. For the negative 1, I'm going to go 3 times negative 1 times negative 1 minus 1 and see if that equals to 6. I'll do that on my calculator. So 3 times negative 1 times negative 1 minus 1. You can barely see what I typed in. Still get 6 equal to 6, so that's also good. Alright. 30. Parentheses are useless for the quadratic formula. I need to get rid of those parentheses, get the problem set equal to 0. So, 2 sets of parentheses to get rid of. The first parentheses, I go 2x times x, 2x times minus 3. 2x times x is 2x squared, 2x times minus 3 is minus 6x. Second parentheses, positive 5 times x is positive 5x, positive 5 times minus 4 is minus 20. So, clearing the parentheses on the left side, I get 2x squared minus 6x plus 5x minus 20. Those minus 6x and positive 5x combine to be a minus 1x. You don't need to write the 1, but it might help. And quadratic formula needs it to be equal to 0. So I'm going to get 2x squared minus 1x minus 20 minus 9. I should do on my calculator right now. Should be minus 29. So I'm going to get x equals a equal to 2, b equal to negative 1, c equal to minus 29. So x equals negative 1 for negative b plus or minus b squared, which is negative 1 squared, minus 4 times a, which is 2, times c, which is negative 29, over 2a, which is 2 times 2. Calculator time, so fraction double negative, I put a 1 in for it, and then plus square root of negative 1 squared minus 4 times 2 times negative 29 over 2 times 2, and I get 1 plus the square root of 233 over 4. Backtrack, change that plus to a minus, and I get 1 minus the square root of 233 over 4. I really don't want to check this, but I'm gonna. So I say that's the answer. To check, I've got to enter that thing a horrible number of times. So I need to go 2 times 1 plus the square root of 233 over 4 times 1 plus the square root of 233 over 4 minus 3 plus 5 times 1 plus the square root of 233 over 4 minus 4. And that whole thing has to equal 9. I can do it, but I don't really want to do it. So clear this out. 2 parentheses fraction 1 plus the square root of 233 over 4 out of the fraction parentheses fraction 1 plus the square root of 233 over 4 minus 3, close out my parentheses, plus 5 parentheses, fraction, 1 plus the square root of 233 over 4, minus 4, close out my parentheses. Oh, I hope it equals 9. Oh, how beautiful was that? Again, if I didn't have this calculator, no way in the world I would check this. Let me check the minus, backtrack. Every time I see that plus, I need to change to a minus. I need to do it 3 times. There's 1 I'm changing to a minus. There's another one I'm changing to a minus. And a third one that I'm changing to a minus. Changed all the pluses to minuses. So now I'm checking the other solution. It's going to give me 9 equals 9 as well. Beautiful. One more problem. Maybe I'll do it and not check it unless it has a really nice answer. So 32 is really unpleasant. Got the parentheses. It's not set equal to 0. I need to get it set equal to 0, and I need to get rid of the parentheses. First parentheses, I go s times s, which is s squared. I'm going to emphasize that's 1s squared. And I still have this s squared there that I'm going to emphasize it's 1s squared. And then I'm going to go s times minus 4 is minus 4s. So the left-hand side, I have s squared plus s squared minus 4s when I clear the parentheses. The s squared plus s squared comes out to be 2s squared. So clearing the parentheses on the left side and simplifying, I get 2s squared minus 4s equals 5s plus 6. I need to minus 5s and minus 6 from both sides. When I do that, on the left side I have a 2s squared. The s terms are both negative, so I add them and keep them negative. I get minus 9s minus 6 equals to 0. So my a is going to be 2. My b is going to be negative 9. My c is going to be negative 6. I'm going to get s equals negative b, which is negative 9, plus or minus the square root of b squared, which is negative 9 squared, minus 4ac, which is 4 times 2 times negative 6, over 2a, which is 2 times 2. I'm going to go positive 9 plus square root parentheses negative 9 squared minus 4 times 2 times negative 6 over 2 times 2, and I get a horrible answer of s equals 9 plus the square root of 129 over 4. Let me backtrack and change the plus to a minus. Delete minus equals, and I get the same thing with a minus. I have 4 s's to plug this number into. It's the very last problem. I'm going to roll the dice and hope I didn't make a math error. If I made a math error and you are one or two students this semester that made it to the end of this video, tell me where my error is and I'll fix it. But I don't think I made an error. But when I get tired, I make more errors than I'm not tired. And this, for whatever reason, doing these hour-and-a-half videos just wears me out. And like I said, I know how to do it, and these are easy for me, so it's got to be equally draining for you, if not more. Alright, so that's everything I feel like saying on the quadratic formula. Hopefully you feel good about it. And the next lecture, section 5.3, is going to be another long lecture, maybe even a bit longer. And we're doing graphs. We're making tables of values. Believe it or not, this calculator, although it can't graph, it can make tables. And we're going to learn how to make tables. I'm going to teach you how to make tables when I do the calculator work for section 5.3. And you're going to hopefully like this calculator even a little bit more than you might like it now. Alright, well, thanks for making it to the end if you did.